Okay, second set of problems, numbers 11 through 20. On number 11, the easiest way to do this would be to just solve the inequality. So that's what I'm going to do. I'm going to rewrite it. First thing you do is multiply both sides by 2. What that does is it literally cancels out the 2's on the right hand side. On the left, distribute. 2 times 2x is 4x. 2 times -3 is -6. Now I'm going to subtract 2x from both sides to get my x's together. So I have 2x minus 6 is greater than -5. Now I'm going to add 6 to both sides. So 2x is greater than 1. Divide by 2, so x is greater than 1/2, which is b. Now don't forget, if I had to multiply or divide both sides of that inequality by a negative number, I would switch the direction of the arrow. Okay, number 12 says Elena is considering buying bracelets and necklaces as gifts for her friends. Bracelets cost $3, necklaces cost $5. She can spend no more than $30 on gifts. Write an inequality to represent the number of bracelets and or necklaces she could buy while sticking to her budget. So it says she can spend no more than $30 on the gifts. That means she can spend $30 or less. So the amount she spends has to be less than or equal to 30. The way she's going to spend that is $3 per bracelet plus $5 per necklace. That has to be less than or equal to $30. So that's the answer for part A. Part B says graph the solutions to the inequality. So I could solve for one of the variables, but whenever it's a context problem, in other words, a word problem, it's easier to keep it in standard form and use the intercepts. So what I mean by the intercepts, 3b plus 5n equals 30. If she doesn't buy any necklaces, for that $30, she could buy 10 bracelets. That's this right down here. If she didn't buy any bracelets, she could buy 6 necklaces. The line connecting the 6 and the 10 is the possibilities of it equaling exactly $30, but she can't spend more than $30. She has to spend less than 30. So that's all of this under here. This is the number of necklaces and bracelets she could buy for less than or equal to $30. C says explain how we could check to see if the boundary is included or excluded from the solution set. So the way we could check is we could check a point. On the line and see if it makes sense to the problem. For example, I'm going to check this point right here. That point is 5, 3. That's 5 bracelets and 3 necklaces, and see if it's equal to 30. And 15 plus 15 does equal 30. So 5, 3 is on the line. Okay, number 13. Jada's making lemonade for a get-together with her friends. She expects a total of 5 to 8 people to be there, including herself. She plans to prepare 2 cups of lemonade for each person. The lemonade recipe calls for 4 scoops of lemonade powder for each quart of water. Each quart is equivalent to 4 cups. N is the number of people, C is the number of cups of water, and L is the number of scoops of lemonade powder. So we're going to choose all of the mathematical statements that represent the quantities and constraints in the situation. A and B both look similar, but B means that 5 people could come and 8 people could come, which is what she expects, anywhere from 5 to 8 people. C says C equals 2N. So what that means is the number of cups that she would have to make is twice the number of people, which is also correct. L equals C. Okay, L is the number of lemonade powder scoops, and C equals the number of cups of water. And in order to make lemonade, it's 4 scoops for 4 cups, so D is also correct. And since we chose B for the number of people, for the number of cups of lemonade, we would choose F. Number 14 says a certain stylist charges $15 for a haircut and $30 for coloring. Haircut takes an average 30 minutes, while coloring takes 2 hours. Stylist works up to 8 hours and needs a minimum of 150 days to pay for expenses. Create a system of inequalities. And it says be sure to define or specify what each variable represents. So I'm going to say X is haircut hours, and Y is hair color hours. Okay, so our 2 inequalities. First of all is our hours. So the total hours she works cannot be more than 8 hours. So the hours is less than or equal to 8. But the money she needs, she wants to be at least 150, which is greater than or equal to 150. Now when we translate that into our actual inequalities, a haircut doesn't take a full hour, so it's not going to be 1x, it's going to be 0.5x. And a hair color doesn't take just 1 hour, so it's not going to be 1y. It takes 2 hours, so that's going to be plus 2y, has to be less than or equal to 8. The money, a haircut is $15, so that's 15 per haircut. And for the coloring, it's 30 per coloring, and she wants that to be greater than or equal to 150. B says to graph the inequalities and show the solution set. Since I let X be the haircut, then I'm going to put the haircut hours along the x-axis and the hair color hours along the y-axis, and I'm going to count by twos on both axes. Okay, and I'm going to plot the lines the same way for this inequality system of inequalities as I did for the previous one. I'm going to use the x and y intercept. So I'm going to do 0.5x plus 2y equals 8. So if she didn't do any hair colors in an 8-hour day, she could do 16 haircuts. So I'm going to put a dot on the 16. In an 8-hour day, if she didn't do any haircuts, she could do 4 hair colors. The line connecting those 2 dots is solid because that's equal to 8 hours, and she can work up to 8 hours. She has to work less than 8 hours. 8 hours or less. So this graph right here represents how many hours she could work doing haircuts and colors. How many haircuts and how many colors. Now I'm going to do for the money. So 15x plus 30y equals 150. If she didn't do any hair colors, to get that $150, she'd have to do 10 haircuts. If she didn't do any haircuts, she would have to do 5 colors to get that $150. That line right there represents exactly $150, but she'd like to have more than $150, so that's all of this. Well, everything above that dollar line. The double shaded area, which is right in here, is how she can get $150 without working more than 8 hours in a week or in a day. Identify a point that represents a combination of haircuts and hair coloring jobs that meet the stylish requirements. Anything in that double shaded area, for example, that point right there, which is 10 haircuts and 1 hair color. And then D says, identify a point that is a solution to the system but is not possible or likely. So even though this point right here, 11.5 is in that shaded area, it's not likely to do 11.5 haircuts and 0.5 hair colors. Okay, number 15 says choose the graph that represents or shows the solution to this system. Okay, so first of all, this inequality is going to be a dotted line because it is just greater than, and it's going to be shaded above. This one, we need to get the y by itself. So add 4x, and you have 3y is less than or equal to 4x plus 12. So this one is solid because it's or equal to, and it's shaded below. So we want the shaded area that is above the dotted line and below the solid line. Above the dotted line and below the solid line. Number 16, this is from Unit 4. The height of water in a bathtub is a function of time. Let P represent this function. Match each statement. Okay, so what you need to remember is this is how it would be written, P of T. P is the depth. T is the time. Okay, so what A means is the depth of the water at 0 minutes is 0 inches. So that means that the bathtub starts with no water. B, the depth after 4 minutes is 10 inches. Okay, if you look at number 3, we said 10 inches. Number 3 says 4 inches. Number 4 says 10 inches, and the time is 4 minutes. So B matches with number 4. C, the depth after 10 minutes is 4 inches. So C goes with 3. And then even though by process of elimination we know D is 1, let's look at it. Depth after 20 minutes is 0. So number 1 says after 20 minutes, bathtub is empty. Number 17, explain the meaning of each of these statements. B stands for the depth and T stands for the minutes. So this literally says the depth at 0 minutes is 0 inches. So the tub started out empty. B says the depth after 1 minute is less than the depth after 7 minutes. So we could say there was less water after 1 minute than after 7 minutes. Number 18, function P represents perimeter, and the length of the side of a square is x. Remember, since it's a square, if one side is x, all of them are x. And to find the perimeter, you can either add up all the x's, or you can use the shortcut to addition, which is multiplication. So we can multiply. So 0 times 4 is 0. 1 times 4 is 4. 2 times 4 is 8. 3 times 4 is 12. 4 times 4, 5 times 4, 6 times 4. So we're going to write an equation representing this. The perimeter of a square with x as its side is 4x. I would accept adding up all the sides. That's fine. Get you there. Okay, it says sketch a graph of the function. When the side length is 0, so is the perimeter. Side length's 1, perimeter's 4, then 8, 12, 16, 20, 24. $19. Let's skip A. We're going to describe the domain. The domain is the independent variable. In this case is time. And time, where the graph starts at 0, it doesn't go negative. So it is all numbers, because you can have half minutes. From 0 to 70. We're talking about the domain of this function. So it's where the graph starts and ends right to left. C says describe the range. Okay, now this is different because attendance talks about the number of people. So we can't have all numbers. We have to have whole numbers. So whole numbers, and you can't have negatives, from 0 to 55. Number 20, we're going to read the graph to decide all of these estimates. Remember, f of t is the F represents the distance and the T represents the time. So this is asking us what's the distance in 5 minutes or 5 seconds. So here's 5 seconds. The distance is 5. Estimate F of 17, which is the distance after 17 seconds. So 15, 16, here's 17. And here's the distance, which is 1. This one says the distance after so many seconds is 8. So when is the distance 8? So we're going to start from the distance this time. Here's the distance. The distance is 8. And we're going to go and find where on this graph the distance is 8. So there's one spot. And if you notice, there's another spot right there and another spot right there. So he's 8 feet from his bike at 9 seconds, at about 20.5 seconds, and 22 seconds. This one says for what values of T. So this is when is he 6.5 away from his bike. 6.5 is right here. I'm going to do a dotted line. Here's 6.5. So let's see when he is 6.5. Here's 1. And then he's 6.5 feet all the way there, there, and there. So let's write this down. So T equals 6. And then this whole time he's 6.5 feet away. So I'm going to say from 11 to 14.5. Then again at 19.5. Then again at 23.5. E says, when is he 10 feet from his bike? He's not ever 10 feet from his bike. So at no time.